All right, so what we're looking at here is a vapor sensor. This is installed in a CBD extraction booth, and in the extraction process, they use ethanol to chill the product. So a few things we want to point out here. The first is the screen. So because of where this is mounted or situated in the CBD booth, this is actually in the extraction booth. So this entire sensor is built to be explosion proof. So the first thing I want to point out is you can see that the display has a glass covering it. So the display actually sits about a quarter of an inch below that protective glass. The purpose of that is so that if there's any sort of a spark inside of this unit, when it kicks on or is transferring signals, that if there is an elevated amount of ethanol in the booth, it will not create an explosion hazard. So the second thing I want to point out, and hopefully I can get a better look at it, are right here, right here, right here, and right here. These four, they look like screws, but they're actually magnetic sensors. And for us to go into the settings and change the calibration, change the vapor type, see any alerts, we actually use a magnet to touch on each of those as needed to toggle through our settings, which is just another part of the explosion proof design of this. So there's no touchpad underneath there. It's all done by magnet, so which is actually pretty cool. It's hard to see on this video, but this housing right here, in order to get it on and off to access all the electrical beneath it, actually unscrews just like you would take a top off of a Pepsi bottle or something. You unscrew it. It's a very fine thread, so you have to turn it, it seems like countless times in order to get it off. But just another facet of the explosion-proof properties of this. And then we're going to move forward a little bit. And as you can see, all these wires, this is actually pretty interesting in that these wires here are the main power wires coming into the unit. It's 24 volts, where it gave us a little bit of a hiccup at the last minute, is that it's not 24 volts AC, it's actually 24 volts DC. So we had to last minute scramble to find a power supply to power this unit, and the only thing that this does is power the display for the unit. And then the rest of these wires, you'll see, hope I can get them separated here, there's 4 different sets of wires. None of these wires, and actually, there we go, so you got 1, 2, 3, and 4 different sets of wires. These all go to independent relays inside of the unit itself, and they essentially act as a same as like a light switch would work, with the exception of they do not provide any power to where they are landing. They only provide a continuity essentially to the relay or sensor or whatever it is that we're running to. So that's a pretty interesting concept, and actually made us have to come up with a unique wiring setup, because this controller, this sensor, is an emergency sensor and will power a 34-inch 17,000 CFM fan. So The fact that these do not provide power coming out of it to start any series of events as far as powering on the fan created a pretty unique situation for us, which we were able to resolve. So that's pretty neat. And then the last thing is this right here will be coming off. It will not be used when the sensor is running, but because of the what the sensor is used for and how fine of an instrument it is, and how, I mean, this finds particles in the air in the billionths. So it's finding very, very, very minute amounts of these gases. So this piece here is only used during the calibration process. We'll end up hooking up hoses to both of these ports here, and then introducing methane gas to the unit, and then calibrating it, doing that. So pretty neat process, pretty intricate sensor, and quite the learning experience on this booth.